Smartphones have truly changed the world. This is because they provide us with real-time information. The problem this video will address has to do with traveling and navigation. Incredible navigational tools are at our fingertips on a daily basis, whether in a car, walking, and increasingly on public transportation. Since 2005, when Google teamed with TriMet, Portland, Oregon's transit agency, to develop a system for public transit directions, navigating public transit has become the focus of thousands of mobile phone applications. While this is great for those with smartphones, it seems that public transit has become more accessible for the privileged. Shouldn't public transit, by its very definition, be equally accessible to all? The city positioning system proposes the democratization of public transit through the installation of simple-to-use navigational guides in all train stations around the city of Boston. New York City has begun implementing a similar idea using digital displays. So why doesn't the MPDA just implement the same idea? Well, the digital displays used by the MTA are estimated at about $2,000 per unit. And currently, the MBTA is $5 billion in debt. The solution? Physical displays that incorporate real-time data rather than digital ones. As an added benefit, these displays appeal to a larger constituency, including those who may be intimidated by digital displays, such as the elderly. Here, we can see the housing unit for the prototype. The unit is constructed from wooden boards with a printed image for display. These are all the components that are utilized in the construction and assembly of the prototype. This diagram shows how the system is wired. The push buttons assigned to each stop return a signal that informs the stepper motors how far to turn based on the user's desired destination. Each of the three stepper motors turns a belt with different values printed on them. The first gives the user their stop, the second their direction of travel, and the third the train they must take. The total price tag for constructing this prototype was around $300 to $350. This means that with the same components in mass production, it's likely that the city of Boston could install these for around $200 per unit. With 119 train stations around the city, installing a city positioning system in each would only cost $23,800. The potential benefits to the city, local residents, and to the MBTA on such a minor investment are major. With a few easy alterations to incorporate extra information, this system could display much of the info available only to smartphone users today. For a hard-working single parent, the time waiting between trains or buses can be used to run quick errands. Foreign tourists with limited or no access to their data plans on their smartphones can utilize this system to navigate the city. It could even be used by people who happen to lose their smartphone. These scenarios and users will all benefit Boston's local economy and the MBTA by creating a more mobile population through ease of access to public transit information. While the benefits to Boston are numerous, the city positioning system has even greater potential in other parts of the world. In the major cities of developing countries, where the income gap is great, smartphones are rare if a 3G network has even been set up. The city positioning system has the potential to democratize public transit information accessibility around the world.